Assalamualaikum and hi everyone. For Focus Emerging Technology and Management, our group would like to present assignment 2 about TPM and OEE. So this is our group member, which consists of me, myself, Hajar, and Marhamah, Suhaili, and also Ellyza. So this is our topic outline. Today we're going to be covering some key information you need to know about TPM, Total Productive Management, which consists of introductions of TPM, Pillar 5F Foundation, and also 8 Pillar of TPM. Second, Overall Equipment Effectiveness OEE, which consists of introductions of EE, losses in OEE, example, and also OEE incorporations. And third, case study, and lastly is a conclusion. So this is the diagram of a pillar of TPM, which the 5S serve as the foundations of the traditional approach of TPM, which was created in the 1960s and consists of supporting activity, also known as a pillar. Hi, today I'm going to cover about Total Productive Management TPM. So what is a TPM? TPM is an innovative approach to equipment maintenance that involve maintenance personnel and operator working in team that focus on eliminate equipment breakdowns and equipment related defects. So this is foundations of 5S, which consists of sort, set in order, shine, standardize, and also sustain. So sort is eliminate anything that is not truly needed in the work area. And set in order is organize the remaining items. And shine is clean and inspect the work area. And standardize is create the standard that perform all the above three activity, which is sort, set in order, and shine. And also the sustain, where we ensure that the standard are regularly applied. Okay, this is a 8 pillar of TPM. First is autonomous maintenance, which operator are responsible for routine maintenance such as cleaning, lubricant, and inspection. So it helps to increase the operator knowledge of their equipment and ensure the equipment well clean and lubricate. Next is a focus improvement, where encourage a small group of staff to collaborate proactively to achieve consistent modest improvement in equipment operation. This help the team from different departments that work together to identify and fix recurring issue. Also bring the company capability together to form a machine that is always improving. Next is a planned maintenance. Maintenance job are scheduled based on the project or measure failure rates. It helps to significantly minimize the number of unexpected stops. Also allow most maintenance to be arranged for period when the machinery is not expected to be in use. Second is a quality maintenance, where we integrate error detection and prevention into manufacturing process. Eliminate the repetitive source of quality fault by using a root cause analysis. Also, it helps to reduce the number of defects, reduce cost by catching defect early. Next, the early maintenance equipment will enhance the design of a new equipment by apply the practical knowledge and understanding of manufacturing equipment that acquired through TPM. It helps the less startup issue, new equipment achievement anticipated performance level significantly faster. Next is a training and education. Training and education will fill in the knowledge gap that required to meet TPM objective. This involves supervisor, operator, and maintenance staff. It helps operator to learn how to recognize a new issue and perform a routine maintenance on equipment. So proactive preventative maintenance procedure are taught to maintenance staff. So next is a safety, health, and environment, where maintain a safe and healthy working environment. So eliminate the potential health and safety risks, resulting in safer workplace. The lastly is a TPM and administration, where apply TPM technique to administrative function. So how it help is it help by cover a few major losses such as a customer complaint due to logistics, setup loss and processing loss and etc.
Okay, so our next topic is OEE, overall equipment effectiveness, which is to measure the efficiency of the machines during its loading time. So there's some quote that I like to share, which is the experience is directly proportional to the amount of equipment ruined. So what is OEE? OEE figures are determined by combining the availability or the performance of the equipment with the quality of parts made. OEE also measures the efficiency of the machine during its loading time. Planned downtime does not affect the OEE figures. So here's some picture regarding the OEE calculation. So what is the OEE losses? There are two types, which is equipment and material and manpower. So for equipment, the speed losses such as reduced speed and minor stopping. For downtime loss is such as setup adjustment, equipment failure or breakdowns. Quality losses are such as rework, scrap and process error. For material and manpower, for material loss such as the material yield and energy losses. For manpower loss, is more to human error, which is waiting instruction, waiting materials, waiting quality confirmation, cleaning and checking. Okay, for far understanding, here's some losses example. We can see availability losses, which is a setup cost, such as an inconsistent times, insufficient skill, poor planning and scheduling, different methods, poor tooling, poor startup control, missing parts, insufficient support, excess startup adjustment. And availability losses of breakdown is such as lack of maintenance, low operator interest, not knowing of the problem, poor training, design problem or inferior material. Example for performance losses such as minor stoppage, which is material not available, changeover at start, ends, jam, misfits, overloads, operator error, operator absence. Another example of performance losses such as speed losses is unclear design spec, poor maintenance history, incorrect setting, poor training, speed reliability reduced and inconsistent material. For quality losses, one of the example for startup losses is poor machine changeover, inconsistent material, no startup checklist, waiting for temperature, pressure and minor adjustment. In process losses, temperature and pressure changes, poor calibration, gorgeous not calibration and so on. Next, how we calculate the OEE. OEE comes from the availability times performance times quality yield. For availability, such as downtime losses, is time available for production minus downtime divided by the time available in production. For performance, which is speed loss, is ideal cycle time times process quantity divided by operating time or working hour. The next is quality yield, which is a quality loss, is total process quantity minus defect divided by total processed quantity. So next, we will pass to Marhamah for the case study.
Let's continue this presentation by diving into the case study. Our group has selected this case study about ramping up the overall equipment effectiveness OEE of a CNC machining center with the utilization of TPM. We will discuss the details of the problem and how they tackle the challenges. This paper presents a case study on improving OEE of equipment in a manufacturing company and also to determine and address the area which act as barrier in implementing TPM. This company, which manufactures steering housing, faced major issue on the lack of stock in feed and tool change over time, which reduced the availability of the machine, which in turn result in tremendous drop in OEE. The current level of OEE for this particular machine is found low at only 54%. To tackle this challenge, the study employed a holistic approach that combined the principle of total productive maintenance (TPM) and single minute exchange of die (SMED). TPM, a lean manufacturing technique, was implemented in phase, focusing on its 8 pillars, including autonomous maintenance, planned maintenance, and quality maintenance. Additionally, the foundation of TPM, known as 5S, played a pivotal role in organizing the workplace for better efficiency. SMART, on the other hand, targeted the reduction of tool changeover times, which is a critical aspect affecting the machine availability. The phase assimilation of TPM is characterized by an imperative emphasis on continuous improvement methodologies. Operators, integrated through this process, engage in a 5S-driven workplace organization while receiving targeted training for skill elevation. Maintenance facets such as autonomous maintenance, planned maintenance, and quality maintenance are meticulously integrated, aligning with the vision of zero breakdown and defects. Concurrently, SMED steps into to address the prolonged tool changeover times. The methodology entails breaking down the internal and external element within the tool changeover procedure. The main objective is to streamline this process and convert internal element into external element, which effectively reducing the tool changeover time by a significant 30 minutes. Transitioning to the quantitative aspect, the enhanced suggestion mentioned earlier have been put into action, resulting in an improvement in the OEE parameters. Availability witness increased from 74 to 77%, and performance surged from 77 to 82%, and quality see a noteworthy uplift from 93% to 94%. Next, we move on to overall OEE calculation. It involved the multiplication of availability, performance, and quality. In this case study, implementing the improved suggestion had led to the enhanced OEE parameter, which resulted in an increase of OEE from 54% to 60%, where 6% OEE increase are observed. These results indicate the effectiveness of the implemented lean tools in improving productivity. In summation, this case study underscored the efficacy of adopting lean manufacturing principle, specifically TPM and SMART, as robust strategies for mitigating operational challenge. The systematic integration of maintenance strategies and process optimization manifests tangible enhancement in the overall equipment effectiveness.
Thank you, Marhamah, on the explanation on the case study. And now we are about to the end of the presentation from our team. Before that, allow me to wrap up with a summary and conclusion from what we already discussed earlier about TPM and OEE. TPM, by its nature of name, Total Productive Management, is a proactive approach to optimize equipment effectiveness through employee involvement, giving empowerment in making decisions, and also to cultivate the ownership among the personnel. While OEE, at the other hand, is a key performance indicator that reflect the performance of the machine. Basically, talking about the benefits, there is a lots of benefits that listed under TPM and OEE, but the most significant among those are with TPM. Basically, we can maximize equipment productivity and indirectly minimize the unplanned downtime. While the philosophy behind the TPM in fostering empowerment and ownership culture, it focuses on continuous improvement and proactive maintenance that will enhance equipment reliability and availability. Similar to TPM, OEE also bringing its own benefit in providing a comprehensive operational efficiency where it helps in identifying and addressing production losses. Having OEE as indicator, it gives insight for the team in making decisions while enables continuous improvement for productivity performance through data-driven. As such, as a key takeaway from this presentation between TPM and OEE, both is eventually cultivates a proactive preventive maintenance mindset that drives continuous improvement with involvement and engagement from the employees. Last but not least, applying TPM in operation and having OEE as key performance indicator
will maximize the equipment reliability, utilization, and overall performance effectiveness. On behalf of this group, I hope that we give some shed lights for the rest of the team about TPM and OEE. With that, I thank you and happy learning. Bye bye.